real-time event-driven data pipeline constructed to ingest, validate, and store high-velocity IoT sensor data. Because developing with live clouds resources can quickly become cost prohibitive. I have built a fully containerized architecture using Docker Compose that runs entirely on my local machine. These are the files in my project: consumer file, MySQL data, producer, and this is env file. These are the some files in my project. When I spin up the environment with a single command, Docker orchestrates three critical components: a GCP pub emulator acting as our high throw output message, Docker; a MySQL 8.0 database that immediately initializes its required schema for persistent storage; and a custom Python consumer service. Okay, and this is my app.api file. See, and this is my Docker file. This is the code in the test app.py. These are all the files containing in the MySQL. And app.py is present in the producer file. Once our simulated edge devices start filtering reading into the IoT sensor data raw topic, the consumer service takes over to establish trust in the data stream before any data reaches our database. The consumer uses the pedantic library to interrogate every JSON payload, enforcing strict contracts that demand perfect formatting, realistic temperature ranges between -50 and 100 degrees Celsius, and valid humidity percentages. If a payload passes these checks, it is batched and inserted into MySQL with an exact UTC timestamp for our audit trail. However, what truly makes this system enterprises great is how it handles failure. When a sensor inevitability malfunctions and sends malform or out of bounds data, our consumer does not crash or silently drop the event. Instead, it catches the specific validation error and intelligently routes that anomalous payload along with the precise reason for failure to a completely separate dead letter queue DLQ topic. This fault tolerance design ensures that while our primary downstream database remains objectively persistent and trustworthy, bad data is securely preserved for engineers to analyze later, demonstrating a highly resilient injection engine from end to end. And this is my README file overall project contents in it. It is the structure. Once the pipeline is running